So let's go. Let us record another video of Turing complete. Stop my cam works this time instead of just doing this all the time. Apparently, this is going to be hard. Because apparently my cam doesn't want to cooperate here. So how do I negate this? This is minus, right? Invert the sign of the number. So in general, what we would do is we would take you and negate you. Well, we want to negate you in any case, right? So let's see. This will work. No, it does not. So 0 stays 0. That would be fun. So 1 is to become minus 1. If we negate you, what is happening? Now we have minus. Then we add 1, right? If you're negative, we add 1. But we add 1 to the negated variant. Does this work? Why can I not make this level work? So first of all, let's have a look. We don't have a byte constant, so we have to do it like this. Oh, so it's quite easy. We just knot it. And then we add 1. This works for negative numbers. Does it? Yes, it works. Of course. Yeah. Here we go. I mean, this is a way to solve it. It's not the most elegant way, but we solved it. Sign negator. The boss. This level has 2 byte inputs and 2 byte outputs. Your goal is to copy from one of the inputs to one of the outputs. The first bit input determines which input you should copy from. The second bit input determines which output you should copy to. Alright. This is quite easy. You decide. Which one we would go to. I assume since in previous levels we would. Take the first one if the so oh no, we need to connect these two, right? For this to make sense. Alright, so I guess then it is this way around. Take the first one. If the light is off. Yeah, of course. I explained it to you the correct way, but then I implemented it the wrong way. Anyways, we solved this level. Saving gracefully. The delay line only allows us to save a value for one tick, but sometimes a component that can save a value for a longer period of time is useful. We want you to build such a component. Alright. Oh, this is what we are gonna unlock. In this level you have two inputs. When the first input is green, update the saved value. The second input is the value. Always output the value. Always output what is currently saved. This is a diagram of the component we want you to build. Yeah, of course. Wait a second. I haven't quite understood this. The second input is the value. Alright. Always output what is currently saved. This is a diagram of the component we want you to build. Save value. Save enable. Okay, this is the value that we want to save. And so we're gonna have to toggle this output. So in case we want to save, it's hard. So in case there's a value, always output what is currently being saved. Alright. So in case there is a value that is to be saved, right? We input it. Alright, this is the value. And if we want to save it, we overwrite this by activating the switch. Does this work? No, it does not. Because there's a circular dependency in this case. Is there any way to... Oh, of course. Because you should enter the switch. So let's use an OR. And then this is still problematic. So the way we would use the OR is not like this. But we would use this one. And you. Is it possible that this is not working? Okay, so this means in any case we're gonna have to use an OR. And we're gonna have to use a switch. The switch only activates in case we want to save. If we don't want to save, does this work? No, we're not allowed to do this. So we're gonna have to use another OR. And this time, this OR is gonna be used to determine okay, if there's a saved value, it stays saved, right? So there's then the next case, the case where this one is true. So in this case we don't even need this, or in case this one is negative and this one is positive, so we want to save the negative value, we would have to make sure that you do not flow. I hope that this will save it. Will it solve it? No, it does not. Why does it not solve it? We output green despite the fact... Oh, you're supposed to close the switch. Not to open it. Yeah, this solves it. Saving gracefully. Now we are going to save bytes. Create a circuit that save or load a byte. When the first input bit is green, load the memory and send it to output. When the second input is green, save the input byte. The output has an enable pin. Enable it only on load. So first of all, no, the second is the save, the value that is supposed to be saved. Here we go. So you determine if we want to save. And I guess loading it means outputting it. So that would mean well, we don't even have to use a switch because this one comes with an activate component, with an activate thingy. Here we go. And now we can save bytes. This is great. Counter, 1-bit decoder. First of all, we're gonna do the 1-bit decoder. Create a component that can switch signals between 2 pins. Yeah, this one is great. So in case the other way around. Yeah, of course. This one encodes a bit. Because a bit can have 2 values, right? And depending on the values that it takes, we can toggle 2 bits. The 3-bit decoder. The same is true for the same variant in 3 with 3 bits, featuring 3 bits. But in this case, and I'm gonna read the instruction. With 3 bits of input, there are 8 combinations. Make a circuit that selects 1 output for each of the 8 combinations. No more or less than 1 bit should be green at a time. Yeah, since there are 8 possible combinations in 3 bits, we can create an 8-bit decoder. And I mean, we could just go with AND gates. This is the easiest variant, or like the most stupidest variant. Guess there might be another way, but this one is clean. It's a little bit tedious, but still clean and fast. In this case, none of them are on. In this case, this one is on. In this case, the second one is on. In this case, the third one is on. In this case, the first and the second one is on. In this case, the first and the last one is on. In this case, the last 2 are on, and in this case, every single one of them is on. This should solve the level. Looks a little bit actually made a mistake. Interestingly, right, which one? So you're supposed to swap places. Interesting. Yeah, of course, it's a binary count up. Wait a second, I'm gonna have to swap these two. To make it clean again. We had our intern add a disable bit to this component. We were tired of looking at him running in circles, and we were looking for other pointless and tedious tasks to give him. So here we are, onwards. There we have it. The logic engine, the registers, the little box, the counter. Little box is a level where we have to store a lot of memory in a small, tiny place. Logic engine is a fun level. I think counter is quick, but yeah. I'm gonna do this level and then we're gonna stop for now. Counting is so fundamental, even insects do it. From counting species can evolve to compare into arithmetic. Wait. From counting, species can evolve to compare into arithmetic. And before you know it, you have apes building computers. Make a device that counts increments once per tick. Alright. Build a counter that will increase by 1 each tick. Additionally, there should be an option to override the counter with a given value. You're given 2 inputs, a bit and a byte. The bit input should toggle between counting and override with the value of the byte. So wait. Oh, so if you override, yeah, okay. First of all, we're just going to take an adder. And the moment you are in count mode, we want to add 1. We're going to feed you into yourself. Are we allowed to do this? No. Interestingly, we are not. Interestingly enough, we are not. But we would have to do it. That means we would probably have to use this thing right here, which will allow us to so usually we have the mux as well. This is great. Because in case we want to enter the override mode, we go like this. And we save every time. And we load every time. There's no scenario in which we don't save and load. So here we are. Input 1, input 2. So now we can take you, feed you back into the adder. Yeah, this does work. So here we go. This should solve the level. And unsurprisingly it does. Here we are. Memory. Little box. But we wanted to stop for now. We wanted to stop for now. So we are going to stop for now. And these two levels I will cover in the next video. Goodbye.